All right, here's a review video for Chapter 10 tests as you're preparing for the last test that we have. Here's the topics we're going to cover. There are also topics that are on your study sheet, so you could fill these in on that, in addition to a few other topics, but hopefully you watch. First, we have solve the absolute value inequality. Let me get this out of the way. Okay, so remember here, the first step when we're solving an absolute value inequality is to remember that there are two possible answers. The first answer is always going to be your original problem, 2x plus 5 equals 9. The second answer is always going to be the same as the original, 2x plus 5, but this time it's going to equal negative 9. All right, sorry about that, I wrote that, getting ahead of myself. Okay, so the equation itself doesn't change. The answer, though, will be 9 and negative 9. And the idea behind that would be that if we covered all of this up, the absolute value of 9 gives us 9. The absolute value of negative 9 also gives us 9. Now we solve each of these separately. So we'll subtract 5. We'll get negative 2x equals 4, and then we'll divide by negative 2. And we'll get x equals negative 2. Over here, same thing, subtract 5. So negative 2x equals negative 14. And then divide by negative 2. So x is going to equal 7. All right, next step will be to take our number line and plot those 2 points on our number line. So we have negative 2 and 7. Now you can put every number on the number line that you want, but you don't have to. And then the key idea here would be that we test points bigger than 7, between negative 2 and 7, and smaller than negative 2. Where do we test those points? We test them in the original inequality over here. So if I test negative 3, I would have the absolute value of negative 2 times negative 3 plus 5. Okay? And I'm trying to figure out if that's less than 9. So the negative 2 times negative 3 is 6. 6 plus 5 is 11. The absolute value of 11 is greater than 9, or excuse me, less than 9, and that is false. Okay? And then I repeat the process for 0. So absolute value, negative 2 times 0 plus 5, less than 9. And that gives me 5 less than 9, and that is true. And then I test 8. So I take this and plug 8 in. Negative 2 times 8 plus 5. And that's going to give me negative 16 plus 5 is negative 11. So 11 less than 9, that is false. Don't forget to take the absolute value at the end. Like I got negative 11. Absolute value of that is positive 11. So I shade where it's true. So I take my 2 endpoints, negative 2 and 7. They're open circles because this is just a less than, an open set. And I shade in between them because that's where I found the inequality to be true. So other possibilities would be shading just the ends, or it could be any combination of that across the top. It could be true, true, false. It could be false, true, true. They could all be false. They could all be true. So you have to test your points. Next, graph the system of inequalities. The first one there is a quadratic, x squared plus 2x minus 8. Now you can use your graphing calculator to graph that if you'd like to. Okay, you could also write it in vertex form by dividing this middle number by 2. So it gives me plus 1 squared. Then I think about what is 1 squared in my head. 1 squared is 1, but I don't want 1. Okay, I want negative 8. So what do I have to do to 1? To get minus 8, I have to minus 9. Now the reason you change the vertex form is so you can see where the vertex is. Negative 1, negative 9. And then from there, it's a lot easier to graph your parabola. Again, this is stuff that you'll learn a little bit more in depth in Algebra 2. But just know that it's out there. And we have done completing the square, so you should know how to do that process. Now I'm going to draw a dashed line from my parabola. Because again, it's not equal to. Now there's all sorts of ways to determine where to shade when you're graphing like this. The most sure way is to test a point. So if I choose a point, let's say 0, 0, that's always the easiest one to test. Okay, I plug that into the original equation over here. So I'll have 0 greater than 0 squared plus 2 times 0. Remember, I can test any point as long as it's not on the line. And if I simplify this, I get 0 greater than negative 8. And that would be a true statement. So this is true. So I'll be shading the inside of the parabola. Okay. And then I graph the 2x minus 3. So I have a starting value of negative 3. And I have a rise over run of up to over 1. So I start at negative 3. And I'm going up 2 over 1 each time. Or I could go down to left 1 to achieve the same thing. And again, I have a dashed line because there's no equal to. And anytime I'm graphing inequalities like this, I always want to extend my lines the whole way across the grid. And again, the only surefire way to know here is to test a point. So if I test the point again, I can choose 0, 0 again because it's not on the line. So if I plug in 0 less than 2 times 0 minus 3, I get 0 less than negative 3, and that's false. So this time my 0, 0 point is false, which means I'll be shading on the opposite side of the line. That will be this side is the opposite side. And then I'm looking for where the two lines intersect. That would be where the green and the purple are shaded. That's my final region. Next, I have solve the equations, use any method. So the first equation over here is quadratic. Typically, that means anytime I have x squared and x's in the same equation, I want to set it equal to 0. So I'm going to subtract 5 each side. And that's going to give me 0 equals 2x squared minus x minus 3. Sorry about that. And then I can either box diamond, or I could do quadratic formula to solve it from this point. So I'm going to try the box diamond because I think it's easier as long as it works. And again, my squared term is always down here, my constant term, and then my x term is in the diamond. Okay, I'll multiply these together to get the top of my diamond, which would be negative 6x squared. What do you multiply to get negative 6? To add to get negative 1, that'd be negative 3 and positive 2. And I fill those back into my box. And then I try to think about the outside of my box, which is going to end up being 2x and 1x. Think ahead because 2 is even. I want to put it in the same row as the even 2 up here. Gives me a 1. And then 1 is odd, so I keep it here. That's negative 3. So the whole purpose of that is to factor this into two factors. I have x plus 1, and I have 2x minus 3 equals 0. Then I separate this into two problems and solve each of them for my two answers. So I would get x is negative 1, and I should get x is 1.5. And if you use a quadratic formula, you should get the same answers. Over here is a little bit different because I don't have x squareds and x's. Yes, I have a squared, but I don't have x squared and x. So here I can just undo. I can solve by undoing. Okay, so first is going to be subtract 4. So I get x plus 3 squared equals negative 4. Second step is to square root both sides to get rid of the square. So the square root and the square just cancel each other out. So I'm left with the x plus 3 equaling the square root of negative 4. Now, before this chapter, you would have said that there's no real solutions there. However, we did learn this chapter that there are imaginary solutions, and there are also two of them. So I'm going to have x plus 3 equals 2i, and I'm going to have x plus 3 equals negative 2i. So when I finish solving this, I'm not going to get an actual numerical answer. It's a complex number. I have 2i minus 3, and I have x equals negative 2i minus 3. It's a little different, but nonetheless, still part of what we did this chapter. Solve by undoing would be the key part there, though. So moving on to the next problem. Suppose an account is worth $150 in the year 2000 and it grows to $375 by 2012. Find the annual growth rate of the account and assume it's increasing by the same percent every year. So anytime we see percentages and growth, okay, growth rates, percent, those are all clues that we're doing y equals a b to the x. Now there's a couple ways to go about doing this problem. I would always start with a table. So in year 0, we're going to call 2000 year 0. It's worth $150. Then we have all these years in between until we get to year 12, where it's worth $375. Okay, and that's what we know. These are x and y values. Now many of you would probably take out your calculator if you have one at home, and you would use your stat and your exponential regression to solve that. And that's okay. But remember, there are also algebraic ways to do it, and that's what we're going to do now. So if I substitute my x and y values in here to my equation, I would get 150 equals a times b to the 0. Now that's nice because b to the 0 is always 1, so I end up just getting a equals 150. And that makes sense because I said that here that 150 is my initial value, and that's what this is in the formula, initial value. So all I really have to do is find my multiplier. So if I substitute my 150 in for a, I do not know what the multiplier is, but I do know my x is 12 and my y is 375. I should be able to solve this problem. So what I'm going to do here is I'm going to divide both sides by 150. Now this would require a calculator, just not a graphing calculator. So if I take 375 divided by 150, I'm going to end up with 2.5 equals b to the 12th. Now, if it was b squared, you'd take the square root. If it was b cubed, you'd take the cube root. It's b to 12th. So we're going to take the 12th root. So on your calculator, that's math x root. Okay? So we would type in 12 first, and then math x root, and then 2.5. And when I do that, it gives me the b value that I'm looking for, which is 1.08. So how does that tell me my growth rate or my interest rate? Okay, so I get b value of 1.08. Now 1.08 is not the growth. I only want to look at the 0.08. How much bigger than 100 is it? It's 8% growth. So the account grew by 8% per year. Okay. Next, given the quadratic function, find the vertex, the x-intercepts, the y-intercept, the domain, and the range. So first would be to graph that. All right, so you can use your calculator to do that. All right, you could also do it by hand because you know the vertex from the formula. And if you don't, what you would do here is you'd simply look at the equation and say, okay, my vertex is going to be the opposite of that number and that number. So -3, -4. Just remember, this is always opposite, and this is always what you see. And of course, you could graph it in the calculator and see what the vertex is. Okay? Now, the x-intercepts, because I graphed it, I already found them. You could also use your table for that. Okay? You can use the graph for that. And remember, if you're using the graph, you're going to have to go second, trace, and you're going to select number 2, which is 0, because if it's not a whole number, you're going to need the decimals. Or the other thing you could do is solve it algebraically. Let y be 0. 0 equals x plus 3 squared minus 4. And then I solve this for x. So I add 4. I square root both sides. And I solve it from there. And that would also tell me my x-intercepts. No matter which way you decide to do it, you're going to get -1 and you're going to get -5. Okay? Y-intercept, again, you can use the graph. And that, in this particular case, is going to be 5. or you could plug in 0 for x. So y equals 0 plus 3 squared minus 4, and that gives you 5. Domain, we've only ever learned about functions that have negative infinity to infinity. Range is always going to be the lowest to the highest, or the highest to the lowest, and it's always going to be your vertex. So the y value of my vertex, okay, is that negative 4, and it does equal that, and it goes on forever. So that's the key here. A lot of people don't get this y value in their vertex as the bottom of their range. Last, solve the system of equations. If it doesn't state a method, you can use any method. All right, so in this particular case, it looks like elimination works out pretty well because I can multiply this by 2. So I end up with negative 2x plus 8y, and that's going to equal, what is that, 36. And then my original equation didn't change, so I still have 2x plus 3y and then 19. And then I add them together. Now the reason I had to multiply first is because of what I want is this action here. The positive 2x and negative 2x to cancel out. And I get 11y, and that's going to equal, what is that, 36, 55, okay, which tells me that y ends up being 5. Now for some reason, when we were doing this in this chapter and we were doing quadratic systems, people just, for whatever reason, just could not remember what to do once you solved for your variable. Well, once I have y, I need to find x. So I take that y value and I plug it into either of these two equations. It doesn't matter which one. They should both work. So plus 3 times 5 equals 19. Well, that looks terrible. Sorry. Plus 3 times 5 equals 19. So I have 2x and 15 equals 19. So 2x is 4, so x is 2. And then this coordinate, 2, 5, tells me where the two lines intersect. Those are some of the topics that will appear on your quiz. Some of them are new, some are review. Hopefully you prepare a little bit tonight, and I'll see you tomorrow.